Well, hello guys, here Mr. G with another video for the grade 12. We are going to be doing another question on organic chemistry. It's very important, organic, and you always do it at the beginning of the year. Okay, so it's going to be helpful for the June examination as well as September and end of the year. But please subscribe for the channel so we can get all the notification videos I post on regular basis. Here we're going to be solving question or answering question 3 from the question paper June 2016. This is going to be about physical properties of the organic compounds. The question say the table below show the vapor pressure of 3 compounds of comparable molecular mass. So guys, you can see here the masses are comparable. I don't know what is going to be asked further away, but this comparable masses is going to be the control variable. I don't know if they're going to ask you here. Now let's see something important. Vapor pressure. They're giving you the vapor pressure here. You need to know that the higher the vapor pressure, the lower the boiling point. This is an important note. The higher the vapor pressure, the lower the boiling point. And you need to know that the higher the vapor pressure, the lower the boiling point, the weaker the intermolecular forces. So you can see here that the intermolecular forces are going to be the stronger one is going to be C, strongest, weakest is going to be A. Here we are. So we know that the strongest intermolecular forces is going to be in C, and A will have the weakest one. This one is before we even look at the question, guys. Okay, so now question 3.1, and define the term vapor pressure. So we have that the vapor pressure is the pressure exerted by vapors at equilibrium with its liquids in a closed system. Guys, this is a definition you have to learn. There's nothing to say there. All you have to do is to learn the definition. Question 3.2, which one of the compound A, B, or C has the lowest boiling point? And we already spoke about that. The higher the vapor pressure, the lowest the boiling point. The higher vapor pressure is going to be A, and therefore have the lowest boiling point. Okay, so it's going to be compound A. Refer to the vapor pressure in the table to give a reason for your answer. All you have to say is it has the highest vapor pressure. All you have to say is that. Guys, this is 3.2.1. Now you have to find out the weakest intermolecular force is the other way. The one that have the highest boiling point, vapor pressure, sorry, will have the weakest intermolecular force. The one that have the less vapor pressure will have the higher boiling point, and therefore the stronger intermolecular forces. So here, which one will have the weakest intermolecular force? Look here, we already answered that question there, guys. So it's going to be also compound A. Okay, now you see the analysis we did at the beginning will help us to answer the question. I told you so. Question 3.3, compound A and B are structural isomers. So that is important. They are isomers here. All right, remember isomers have the same molecular mass but different structures. The structural isomers have the same molecular mass but different structure. That is important. What type of structural isomers are compound A and B? Now remember there are 3 different types of structural isomers: chain isomer, positional isomer, or functional isomer. In previous video we mentioned this one, and even there's a video explain about isomers. But now the only one that will affect the vapor pressure and therefore the boiling point will be the chain isomer, because it becomes either a smaller chain or bigger one. So guys, this one is going to be a chain isomer. That is nothing to say about that. It's quite simple. It's the only one that will affect that vapor pressure. Fully explain the difference in vapor pressure between compound A and B. Okay, now this question said fully explain the difference in vapor pressure between A and B. So we here are working with A and B. Now remember we mentioned already that those two are chain isomers. So it means that the surface area of the two of them are going to change. Okay, now which one have the greatest surface area? Well, the one that have the less vapor pressure. So a B will have a larger surface area than A. Right, so B will have more surface area than A, and let's going to start writing this one here. So that is the first thing you have to say. B has more surface area than A. How do I know that? Because they are chain isomer, guys, and B has a lower vapor pressure, therefore higher boiling point and the stronger intermolecular force, so the surface area must be greater there. Now, if it's greater surface area, the strength of the London forces is greater there. Second important thing, B has more sides for London forces. Remember, they are alkanes, and the only type of intermolecular forces is London forces, and therefore stronger intermolecular forces than A. And we carry on. If the intermolecular forces is stronger, therefore there is more energy needed to break them. Therefore, more energy is needed to break the intermolecular forces in B than A. Guys, that is the full explanation, and then you will end saying that B has lower vapor pressure. So that is the explanation, and in the way they always want you to answer these questions. And that one was question 3.3.2. Question 3.4, write down the general formula for the homologous series to which compound C belong. Now, compound C, guys, is a haloalkane. You can see here easily they have a halogen. So it's the general formula for the halogens or haloalkane, let's say, no halogens or alkyl halides. And guys, this is another thing you have to just learn by memory. You have to memorize that one. It's no other way. So the general formula is this one here, CnH2n plus 1x, in which remember X is one halogen. So X is going to be Cl, or it's going to be I, or it's going to be fluorine, or it's going to be any halogen, Br for instance. So that is important to remember. And question 3.5, just to finish, refer to the type of intermolecular forces, explain the difference in vapor pressure between B and C. So we go back here, B and C. B is going to be hydrocarbon. It is going to be an alkane, and therefore it have London forces only. London forces only. But in a haloalkane is also going to be dipole. That is important to know. And London forces. So it has dipole and London forces. Guys, dipole is stronger than London forces. That's all you have to say, but we're going to write it right here for 3.5. So you are going to say that B is an alkane with London forces only. C is a haloalkane with dipole and London forces. And now you are going to compare. London forces are weaker than dipole forces. Therefore, less energy is needed to break the intermolecular forces in B. Remember, B is the one that have the London forces, so B than C. And this is the end of the question. B is an alkane with London forces only. C is an haloalkane with dipole and London forces. London forces are weaker than dipole, and then less energy is needed to break the intermolecular forces in B. Let's fix this one here, guys. This one is intermolecular forces in B than C. There we go. And that is the answer for the question, guys. This is the end of this question 3. I hope it helped. If it helped, if you understand, subscribe for the channel, and I'll see you next time with another video. But for now is all. Thank you for watching. I'll see you next time. Mr. G here.